Hello and welcome students. In today's session we will discuss two important topics of solid state. First is the formula of a compound and number of voids filled, and second is calculations involving unit cell dimensions. So let's start with the first topic, that is formula of a compound and number of voids filled. Students, in this topic I will tell you four important points. If you will understand those 4 points, you will be able to solve all the problems related to this topic. So let's start with the first point. In case of FCC, HCP and CCP, number of atoms per unit cell is equal to 4. In case of BCC, number of atoms per unit cell is equal to 2. In case of simple cubic lattice, or we can say in case of primitive unit cell, number of atoms per unit cell is equal to 1. The second important point is that the number of octahedral voids, are always equal to number of closed packed particles. Whereas number of tetrahedral voids are always twice the number of closed packed particles. For example, if in a crystal lattice number of constituent particles or number of closed packed particles is equal to n, then the number of octahedral voids which are present in that lattice is also equal to n. Whereas if the number of closed packed particles is equal to n, then number of tetrahedral voids are twice the number of closed packed particles, means it is equal to 2n. Students, the third important point is that in case of ionic solids, the larger ion, that is anion, always forms closed packed structures. In ionic solids, anion always forms closed packed structures, whereas the smaller ions, that is cations, always occupy the tetrahedral or octahedral voids. So cations, which are the smaller ions, are always present at voids, whether tetrahedral or octahedral. If the size of the cation is very small, then it will occupy the tetrahedral void. If it is comparatively larger in size, then it will occupy the octahedral voids. The fourth important point is that it is not compulsory that all the tetrahedral and octahedral voids will be occupied. Some tetrahedral or octahedral voids may remain vacant also. So the fourth point is that not all tetrahedral or octahedral voids are occupied. The fraction of tetrahedral and octahedral voids which are occupied depends upon the chemical formula of the compound. Students, now we will discuss some problems which are given in the NCERT based on this topic. In that problems, you will understand how these informations are useful. Students, this is a solved NCERT example. Let's see how this question can be solved by using those 4 informations that we discussed earlier. In this question, it is given that a compound is formed by 2 elements, X and Y. Y forms CCP lattice, whereas X occupy octahedral voids, and all the octahedral voids are occupied. As we know, the number of octahedral voids are always equal to number of close packed particles. So if the number of close packed particles y is equal to 1, then number of octahedral void would also be equal to 1. So the formula of the compound is xy, because the ratio of x and y is 1:1. So this is the answer of this question. The formula of the compound would be xy. Students, now I will take one more question. This is again NCERT solved example. In this question it is given that a compound is formed by two elements A and B. B forms HCP lattice, whereas A occupied 2/3 of tetrahedral void. It is important point here that not all the tetrahedral voids but only 2/3 of tetrahedral voids are occupied. Let's see what would be the formula of the compound. Students, as we know, the number of tetrahedral voids are always double the number of close packed particles. So if the number of close packed particle is 1, then number of tetrahedral void would be equal to 2, means the formula of the compound would be A2B. But this would be the case if all the tetrahedral voids would have been occupied. But here it is given that not all the tetrahedral voids but only 2/3 of them are occupied. So it is multiplied by 2/3 and it becomes A4/3B. And as we know, in a chemical formula of the compound, atoms are not given in fraction, so it is multiplied by 3. So it becomes A4/3 into 3B3. So the formula of the compound would be A4B3. Students, now I will take one more question, which is the NCERT in-text question. Students, in this question it is given that a compound is made up of two elements M and N. N forms CCP lattice, whereas M occupy 1/3 of tetrahedral void. 1/3 of tetrahedral void. So what would be the formula of the compound? This is the question. Now, as we know, the number of tetrahedral void is always the double the number of close packed particles. So if the number of close packed particle n is equal to 1, then number of tetrahedral void would be m2n if all the tetrahedral voids would have been occupied. But this is not the case. Here only 1/3 of tetrahedral voids are occupied, so it is multiplied by 1/3. And as we discussed in the previous example, that the number cannot be in the fraction, because in the formula of the compound, atoms are not represented in the fractional form. So it is multiplied by 3. 2/3 into 3 m and 3, so it becomes m2 and 3. This is the formula of the compound. So students, this topic is completed. Now we will discuss the next topic, that is calculations involving unit cell dimensions. Students, in this topic first we will see the formula of density of unit cell, then we will solve the numericals related to that formula. But before starting the topic, I would like to tell you that density of the unit cell is same as the density of the substance. So let's see the formula of the density of unit cell. As we know, density of a substance is equal to mass upon volume. So in the same manner, density of unit cell is equal to mass of unit cell upon volume of unit cell. In mass of the unit cell is equal to number of particles which are present in the unit cell into mass of each particle. In volume of the unit cell is equal to A cube. Here Z is the number of particles which are present in the unit cell. or number of atoms which are present in the unit cell, and m is the mass of each atom. Now, as we know, number of moles is equal to mass of a given substance by molar mass, and it is also equal to number of constituent particles which are atoms, ions or molecules by Avogadro number. To solve the problems related to mole concept, generally we use these two formulae. So we can equate these two formulae. Mass in gram, given mass in gram, by molar mass is equal to number of particles N by Avogadro number Na. So if the number of particle is 1, means number of atom is equal to 1. So for one atom, it will be, mass will be equal to m by Na. Mass will be equal to m by Na. So for one atom, mass of one atom can be written as m by Na. So it becomes m by Na, where this capital M denotes the molar mass of the substance and Na is the Avogadro number. So this is the formula of the density of the unit cell. In this, by using this formula, we can solve the numericals related to density of the unit cell. In those questions, out of these 5 parameters, 4 will be given, and 5th can be find out by using those 4 parameters. So let's take one example. Students, this is a NCERT in-text question, and let's see how this question can be solved by using formula of density of unit cell. So first I am writing the formula of density of unit cell. It is Zm AQ Na, where D means density of the substance or density of the unit cell, Z means number of atoms in that unit cell, M means molar mass of the substance, A means as length of the unit cell, and Na means Avogadro number. So let's see which parameters out of these 5 are given in the question and which has to be calculated. So we can see here, density of this unit cell is given, that is 8.92 gram per centimeter cube. Density is given in the question. Z is also given because copper crystallizes in a FCC unit cell, and we know number of atoms per unit cell for FCC is equal to 4. So value of Z for this question would be 4. As length of this unit cell is also given. As length is 3.608 into 10 raised power minus 8 centimeter. So as length is given. Avogadro number is a known number, that is 6.022 into 10 raised power 23. So the only unknown parameter is molar mass of the substance, and this is our question. We have to calculate the molar mass of copper or atomic mass of copper. So first I am rearranging this formula for the molar mass. Molar mass is equal D into AQ into Na upon Z. Now we can put all these values in this formula. D, density, is equal 8.92 gram per centimeter cube into A means as length is equal 3.608 into 10 raised power minus 8 centimeter whole cube into Avogadro number, that is 6.022 into 10 raised power 23 by Z. As we discussed earlier, that number of atoms per unit cell for FCC is equal to 4. So value of Z would be 4 here. 4 atoms. This is 6.022 in 10 raised power 23 atoms per mole. Students, if you will solve this, you will get 63.1 gram per mole. This is the molar mass of the copper. The atomic mass of the copper would be 63.1 U, because the unit for the atomic mass is U, that is unified mass. So students, here we have solved this numerical based on the density of the unit cell. The similar kind of numericals are given in the NCERT exercise also. You can try those questions as well similarly. The next topic I will cover in the next video. Thanks for watching.